Problem number 25, it says, assuming that dy dx of sine, or the derivative of sine of x, is cosine of x, and that the derivative of cosine of x is negative sine of x. So now what we need to do is we need to prove d dx of tangent is secant of x squared. Now this is the one that we did the other day in class, and I knew and the reason I did it the other day in class instead of having you just write it down from the textbook is because I knew it was one of your homework problems. So even though we've seen this one once before, let's do it again, because I think when you see something a second time around, it makes a little more sense. So really what we want to do is we want to take the derivative of tangent of x. Okay? Well, that means that tangent is really the same as sine of cosine, or sine over cosine of x. So we want to take the derivative of this. Well, in order to take the derivative of that, we would do this whole u is sine of, the quotient rule, u is sine of x. U prime then, based on this information, right? U prime then would be cosine of x. And then we would choose for v, we would say v is equal to cosine of x, and then v prime is negative sine of x. Okay? And so then we just do the quotient rule. So the quotient rule, and you've got to be very precise, and I would encourage you guys to look it up in your textbook every time until you've memorized it. And it's vu prime minus, it's minus the opposite of that. So it's always going to be vu prime minus u v prime all over v squared. Okay? So now to find the derivative of this, what I want to do is I'm just going to plug these values in. So for v, I've got cosine of x times u prime, which is cosine of x, minus, and then u, which is sine of x, times v prime, which is negative sine of x, all over cosine of x squared. Well, if I multiply the stuff through and expand and simplify on the top, I really have cosine of x squared plus sine of x squared all over cosine of x squared. And then, and I'm going a lot faster today because we had to do some review, but we said that when you think of a right angle triangle and you have theta, then this would be the opposite, this would be the adjacent, and this would be the hypotenuse. And we said that sine of theta squared plus cosine of theta squared is the same as the opposite over the adjacent squared, which is going to be added to cosine squared, which is the adjacent. I said it wrong, but I wrote it down right. Opposite over hypotenuse squared, adjacent over hypotenuse squared. Well, then that gives me o squared over h squared plus a squared over h squared, which gives me o squared plus a squared over h squared. Well then, if we look at this and we apply the Pythagorean formula, o squared plus a squared actually equals h squared. So I've got h squared over h squared. So really what I've just proven is that sine squared of theta plus cosine squared of theta is equal to what? 1. So all this stuff here is the same as 1. So I've got 1 over cosine of x squared. Well, 1 over cosine of x squared is the same as secant of x squared. And I haven't been writing it down, but all of this stuff is really tangent of x prime. So really, what I've done is I've just proven that d dx of tangent of x is equal to secant squared. So that was easy because we already knew that one. We did it on the other one of the example problems. But there's a part B to this, and I want to do the part B so you kind of get used to this. Okay? So now for part B of 25, they give us a different proof that we needed to prove, which was, let me go back and figure this out. It was secant. All right. So now for part B, so any questions on this? Now this is the one we did yesterday, and I remember going through it, and you guys seemed really overwhelmed. How do you feel about it today? Does it make sense?
Yeah.
That's all we've got to do. So when we learn it the first time, it's overwhelming. There's too many steps. When we go through it the second time, it makes more sense. And we may have to go over things 3 or 4 times. But I want you guys to let me know. So now, here's where you're going to help me. For part B, we want to find the derivative of secant of x. And they've even told us that we should end up with secant of x, tangent of x. What is secant of x? 1 over cosine. So I'm going to take the derivative of, well, 1 over cosine of x. Now how do I do that? Still the quotient rule. Still the quotient rule. I'm going to let u equal 1. So what would u prime be? 0. I'm going to let v equal cosine.
V prime is negative sine.
Good. V prime is negative sine. Who remembers what the formula is so I can write it down?
V of u prime minus u of v
Plus.
prime over v squared. No, it's minus.
Plus is the product rule. So I'm going to plug in v, which is cosine of x, times u prime, which is 0, minus u, which is 1, times v prime, which is negative sine of x, all over v squared, which is cosine squared. So this goes to 0, and I'm left with sine of x squared all over, or no, it's not squared, it's just sine of x, right?
Isn't it negative sign?
No, because you have a negative 1 and times the negative, so it's positive, right? Over cosine squared. Well, hey, that doesn't look like secant times tangent, does it?
No.
Well, let's think about this. What if I were to say sine of x over 1 times, well, wait. Let's do sine of x over cosine times 1 over cosine of x. What's that?
Sine of x over cosine of x.
Yeah, this is tangent. This is what? Secant. So then I could say that this is tangent. And I did it backwards on purpose.
Wait, why did you, where did the squared go?
Well, what's cosine of x times cosine of x?
Cosine squared. Oh, so you just did, they kind of took it out.
And so the derivative then of secant of x, whoops, I got a little crazy there on my writing it down because I was looking at the screen, is in fact secant of x tangent of x. Yeah, you want to see the rest of it? Does that make sense? So to recap of what we did is we just said secant of x should be, the derivative of secant of x should be secant tan. So we just did the product rule, or the quotient rule, I'm sorry, because secant is really 1 over cosine of x. So we let u equal 1, u prime it would then be 0, then v is cosine of x, and v prime would be negative sine of x. Plug it into the quotient rule formula. I get cosine of x times 0 minus 1 times negative sine of x all over cosine of x squared. That yields sine of x over cosine of x squared. Well then, if I separate the x's, or the cosines, right, cosine and cosine, and I have sine of x over cosine, which is tangent, and 1 over cosine of x, which is secant. By using the commutative rule of multiplication, I could flip-flop those, and I end up with secant of x, tangent of x. Does that make sense to you guys? Any questions?